Hello, I'm Bill Raggio at Rayotek Scientific, and I want to talk about my favorite material, Sapphire. What we have here is a sapphire window. This is a spectacular material. It has the highest temperature ratings of any optical material available. It also is second to none, actually I should say second to diamond only in hardness. It's incredibly scratch resistant. It transmits deep into the UV and way into the IR. It's got a number of amazing mechanical and physical and optical characteristics that no other material has. And one thing you'll notice when you handle sapphire is it's heavier than glass. It's significantly heavier, actually. It almost feels like a piece of metal. It's also a very good thermal conductor. It's also a crystalline material, which is different than a glass. It's very different than a glass, which is amorphous. The only downside to a crystal material, as far as I'm concerned, is it can't be melted. What you see here is what you get, but that's a pretty incredible material. The ideal orientation for sapphire is what's called the C-axis, sometimes the Z-axis or the optical axis. The reason it's called that is because that's the one symmetric axis in what is otherwise asymmetric crystal structure. If you look at this window in different directions, you'll actually see a different crystalline structure within the sapphire. Some materials aren't that way. No matter which direction you look at it, it's got the same crystalline structure. In this case, we have designed the C-axis to go straight through the face, perpendicular to the face of this. That's the strongest orientation. It's also the most costly, but it gives you the best sapphire material that you can have. What that means is around the C-axis, the sapphire expands equally when it's subjected to heat, thermal expansion. It distributes heat through thermal conductivity uniformly, and most importantly, it's the mechanically strongest material when it's in the C-axis orientation. Now, why would anybody use any other orientation except C-axis? Considering that we start off with a large chunk of sapphire. It gets chopped up into pieces to create something like this. You have to maintain that C-axis orientation through the entire process to make sure you don't lose it. If you do lose it, then we have what's called random orientation. In other words, you didn't keep track of the orientation, you don't know what orientation it is. That sapphire is actually lower cost because you don't have to keep track of that orientation. What other orientations are there? There's A-plane, there's R-plane, there's M-plane, and some other more exotic ones, all specially tailored for very unique applications. For more information or watching me, because I'm handsome, click on the link below.